Всем привет. Меня зовут Алексей Москвин.
Hi there, my name is Alexei Moskvin, and this is Daniil Sadirin, my colleague, and we are going to talk to you today about a new approach to automated generation of exploits for major web applications. Jointly with Alexei Plechov, we developed and implemented first version of Application Inspector. It's a statistic analyzer that generates exploits. We talked about it with Sergei Gordechik in 2013, and then in greater details in 2014 in this conference. Since then, a lot of time has passed. We are in AI4 version, Application Inspector 4.0 version, and here are the most important steps and the most important changes introduced into the system. It has become better, more scalable, etc. A lot of improvements have been made, and Mr. Koshetkov talked about it yesterday. Not yesterday, I'm sorry, last PhD conference. So this is what we are dealing with, and we are now developing a new kernel that allows to identify more vulnerabilities that jeopardize web applications. In order to understand what are the types of vulnerabilities we are now capable of finding, let us start in the very beginning with the classical vulnerabilities. In this slide, you can see part of the code. It's a Java code, and you can see here all the elements of vulnerable code that one would need to analyze. Right, that one would need to analyze in order to come up with an exploitable application and to give information on whether or not his code is vulnerable, so that he can check vulnerability by way of using this exploit. So we should have a database on potentially dangerous functions, a general understanding of what can be used as an entry point. Here our entry point is a creation of file object. And what follows is that we need to analyze the course of execution and come up with the achievability conditions. These are classical vulnerabilities. You can look at various languages, various entry points. We can analyze all kinds of requests and calls. But presently, this is something that is very simplistic, very straightforward, and a lot of static analyzers allow us to identify these kind of vulnerabilities in their own ways. And we are going to talk to you today and demonstrate to you today an approach to find vulnerabilities through exploits for more difficult, complicated kinds of vulnerabilities. And let me give you some more information what type of vulnerabilities we're talking about. In this slide, we're giving you an example on CVE 2020-28-248. Looking at the official information on this CVE, you'll see just 3 lines, and all you can understand is that it's exploitable heap-based buffer overflow, and that's it. It's not enough to understand what goes on there and to understand whether or not the Node.js developer needs to do something about it, remediate it in any way. Well, this is nothing that can help the developer do that. You can see a PNG image library. It's part of your standard Node.js, and so if you're interested, you can follow the link on GitHub for this project. Anyway, and we're even more lucky. There's a write-up on this topic. So if you're interested, a lot is being said there. But anyway, they're talking about the vulnerability itself, not the way it can come by or not come by in a web application. So what follows is that A, your regular competences and skills of Node.js developer are not enough to write a code that would be invincible to this kind of bug. Yes, the developer would be able to effectively patch the library, but how about the new non-public vulnerabilities and how dangerous they are for his particular web application? Probably they're not dangerous and he doesn't have to do anything. So this is the point of our research. This is what we learned how to find. We learned how to automatically identify these kind of vulnerabilities in particular web applications. Ours is a statistic analytics tool. In one of the previous conferences, we gave information on how it works, and these are the three main bullet points. Three things that you need to do to analyze the source code. You need to have an intermediate instance for subsequent analysis, and then you should use that one to come up with a logical formula, like an abstract program interpretation, and then we should send it to a symbol solver to understand what we've got. So this is something that we've worked additionally upon to find the vulnerabilities I have in mind. We're now more accurate in analyzing execution, even taking recursive action into account. Another important task was to pass the data on binary vulnerabilities and introduce the particular exploits that are related to binary vulnerabilities. So this is our algorithm in short. So now, the location in which we're going to demonstrate it. In order to demonstrate this approach and this algorithm, we picked PHP object injection. It's fun stuff, a lot of vulnerabilities there, a lot of stuff to, do our trainings upon and to search for. In PHP object injection, what you have is vulnerabilities that look very much like your classical ones. You can see here destruct, which is our entry point. Its logical method call. Then destructor starts to execute, and we get a dangerous function there. So this is your standard management flow. And we need to calculate everything and then make our conclusions. Classical way of operation with classical vulnerabilities. But there are also binary vulnerabilities, many of them. Stefan Acer mentioned it back in 2010. A lot of similar presentations were done at Black Hat and other conferences. And he was telling us that everything is very vulnerable, everything is really bad. And he was talking to us about the technique, but not about particular exploits and how to deal with it and how to check web applications for vulnerabilities. So these are the mentionings of his presentations, and then Evanid suggested a new way of exploiting this type of vulnerabilities. Well, to be quite frank with you, when Stefan was making his first presentation, and it's been more than 10 years, a lot of bugs have been found. Here we're just demonstrating a very smallish couple of branches of our bug tree. One ticket is related to the next one, and that one with the other one. Some of them are interdependent, some of them not, but this is just a small part of the bugs. And this was done by multiple researchers. Now, just a couple of words about whether or not the binary vulnerabilities are dangerous. Well, this is not your regular function. Code execution is done on the level of operation system rather than PHP. So what you get are different sets of benefits. So Daniel is going to comment on the first video. First video, please. Please come here. Yes, we're going to look at a binary exploit in MyBB 1.8. Could we pause a little bit? So we make use of Stefan Messer's technique of reading a memory of PHP leads to the fact that we can get addresses of system structures and functions from executable file. Next, what we can do through recording into PHP memory, we rewrite GMP buff structure. After we rewrite GMP buff, and we can continue the video, please. Right. This is the GMP buff. After rewriting GMP buff, we get control over the registries. And next, we get RCEs, like in classical exploits like buffer overload. And the code is performed with disabled functions and open-based here. But you have to have a lot of calls to get function addresses from the memory. And this is to illustrate how it all works and how we bypass SLR by reading an executable PHP file from the memory. Unfreeze it. Can we go on with the video? I think it's paused. Right. So here we can see back connect working. And now we would like to demonstrate the next video, okay? Yes, this one. So here we can see a different use case of binary vulnerability. Let's assume we have two websites, and on port 80, there's a website with Drupal vulnerable to CVE 2019-6340. And a second website on port 8080 doesn't have any bugs at all. HTTPS is being used on the websites, and by using HTTPS, we need to generate private keys, which is usually done by web server administrator. The keys on the disk would have user and group root, and when Apache would be started, it would have root privileges, and it would read the private keys and subsequently create processes with corresponding privileges. So after reading the private keys, they stay in the memory, and when we have this kind of vulnerability, it allows us to read through all the layouts, Apache config, and find the addresses of private keys. So basically, they are stored in the user group root in the disk. So through binary exploit, we bypass access rights to that particular file. Thank you. No, you don't have to repeat this video. Thank you. Thank you for the demonstration. Right. One other thing that I would like to point out is that this kind of exploit is something that goes through several calls, several requests. You first need to get information on memory addresses, then make use of it. So this kind of vulnerabilities depend on how and where PHP exists. And they are quite dangerous. They can bypass base their disable function, and this is pretty serious. And let's keep going. Just a couple of words about how OP on PHP works. This is packagist repository. Package repository. Packagist is the PHP package repository that could be used by various developers just by using this simple commands. But this simplicity is to a certain extent deceitful. And when identifying vulnerability in one package, you can get a whole pack of other vulnerabilities elsewhere. It's not really very secure here. So one other demonstration of our scanner of finding a vulnerability. Here we installing Laravel 8.8.3.12. This is for PHP version 7. So what we do next, it's enough to launch autoload, and FreeMark is already available to CMS user. So we execute the commands. Let's have a look what happens next. We launch the analyzer. Exploit goes through the eval, and it's going to work in Laravel. Laravel is the framework that is most popular, and yet code execution is what you see here. And here we just check that what we generated really does work. A real script that sends the call, and this is how we make the script work. And then we check to make sure that RC is really there. So this is to illustrate that we can identify not just your regular vulnerabilities, but all kinds of other vulnerabilities. Just in one package, so many vulnerabilities. We're going to show you that if we search for this opus, then you also choose dependencies, and you can see here millions of downloads. And now on to binary vulnerabilities, starting with the simplest ones, the ones that are not very detrimental, but quite unpleasant. When we looked at the so-called magic PHP methods, we did identify a unfixed DOS. we wrote to bugs page PNAT, and they responded that it's known, it's bug number this and this, 64196, submitted like 9 years ago. And then developers said that it's not security issue. We want the programmers to work on that. So they're saying it's not security issue. But in fact, bug 64196 is about clone method and some other interconnected bugs, very much like the tree I demonstrated earlier. Anyhow, a lot of use cases, a lot of bugs that are encountered in multiple places. So in order to exploit it, all you need is to address a field, a massive element in this field, object field as an element of array, and then we would call offset get, and there you go. And you have your DOS. So when I was talking to you about the classical vulnerabilities, from what we see in the bag, we see a different pattern where we address the fields as elements of array. And we can search it this way, and we found it in sodium campat. It's a smallish exploit. You only have to find 2 requests, so it's not a big deal. And still, this package is used in Joomla. And there are multiple ways to. You don't have to request serialize. You can use memcache, etc. So what I'm saying is that the idea behind this exploit is that the developer at the point of development can be said that, look, here is your DOS and you can fix it right away. Rather than thinking about how to send the data, you can fix it or not fix it and understand, take everything for face value. Another bug, a little bit more interesting. These are execution codes unfixed. Like I said, a lot of bugs have been found since Stefan Escher made his statements. These are the bugs that we found, and nobody have reported it earlier. We can't report it at this point because they're not taking it in. Look, as if PHP 5 is not being used. Although it's not. It's not true, obviously. And now Daniel is going to say more about this bug, this particular one. Yes, the bug is insufficient check of type. So when a GMP object is unpacked, you need to rewrite handle field to an object, another PHP object. And when you finalize unpacking of GMP object, what you get is the opportunity to rewrite object fields with a particular ID that were pre-written into handle field. And in order to rewrite GMP objects in code field, you need to have the code line the way it's on the slide right now, like the one you see on the slide right now. And you need to find an object that would be good enough to rewrite properties. And after doing that, you would realize that this vulnerability allows to build a stable exploit that only asks for several requests and is not dependent on system structure. You don't have to search for any memory addresses or anything. Right. And we started to think how is it used in real code. There is composer there. If composer is used by default, according to the manual, first object created is composer afterward, which is great. It allows to include files, but like Daniel said, you need to rewrite the handle field. That would it would be enough to just put one. More often, it's not one; it's true, because in PHP there is a type transformation. So this is the pattern. Just true, and then composer is our object. And that's it. Aperture includes Symfony for all the versions. And could we have the video, please? Yes, so we install Symfony by default, not all of it. 2 packages from Symfony would be enough into JSON, a composer, dependence injection and routing. And this is your standard use of these packages. The latest PHP, version 5, that you can no longer fix. So what happens next? We install the composer. We launch these packages. We download the stuff. We send it over to the scanner. Bistro is a PDF, like find us passes and collect logical formulas. This is what we get. Yeah, great. 60 exploits from various places. What we do next? We saved exploits into files. We want it to be visible. Besides, it's not very convenient to demonstrate other ways. So we launch this exploit and we check. And it's far from being an easy exploit. And a simple script does it for us. It sends the call for HTTP server. So we send over the file with this exploit. And you can scroll it all the way to RC. Let's have a look what's in the code. This is a custom unserialized. Like Daniel said, we unpackaged and then we have to rewrite the handle. It's not fixed, by the way. Although there were multiple tickets, but it's still not fixed. This is destructor. Remove bindings. All the way to the dangerous function. This is our dangerous function. And it only has this value of true. And that alone would be enough to include it. Just to illustrate, remember I was talking to you about PVFs, and PVFs already known, and you can create a list for each of them. And here PVFs are Not really PDFs, they're kind of constructs. We were addressing fields as array elements. They come from the binary research. Anyhow, you should send this field to here, and this is a GMP object. And unpackaging of the GMP object would lead to rewriting the field of composer, class map, class loader. And you can see it here, what it leads to. So the developer doesn't have to think it really hard over it. It's already there for him. And the fact that Scanner has calculated it all allows to send research information over. And those who are dealing with language structure, they can get this information and understand whether or not there is a problem. You don't need to have too many experts. You just have to execute the script and look at what happens in the code. Like I previously mentioned, these patterns make your work straightforward, showing you all, highlighting all the functions that you need to attend to. Simple execution, and what you get is the final result. In the very end, you're going to see a link to the project website. Actually, it's much more interesting to study the information on your own. Please join, and I think it would be of interest to you. Right, that is it. And you can see class map field was rewritten. Yes, so those were interesting bugs, but we can actually dive even deeper. Composer is the first by default, and it's true. It's true for Drupal. You can actually go ahead and try it for yourself. Composer doesn't have to be the first one. What's then? Well, then you need to keep going and analyze it and try and use other deserialization variants. It actually works for a regular code. It's not that convenient to work with fields, though. Anyhow, this is a different exploit that our analyzer managed to find. What we have here is the exploit that works with fast destructor, the implicit vulnerability. So we found a peculiar thing, that if you have this var equal 1, this var equal 1, then in PHP we are not going to have var equal 1. If var used to be our object, then var would equal 1, and then we would call the structure of this object. So we're deleting this object, that's why we call the structure. An interesting analysis tool. The request may happen or not happen depending on the initial data. And a lot of these type of vulnerabilities can be seen. And this is what our scanner allows to identify. It would allow us, and then now we added binary bugs on top of it. So the structure is var equal 1, and we unpackaged it var object A, and prop is the reference to var. So we unpackaged it with var. The structure was called, the structure worked, and then there is this field. But our field is a reference to var, so var got rewritten. So rather than having 1 in eval, we have something different in eval. Cool, right? And in Symfony, in real code, it turned out to be slightly more complicated, but we did manage to calculate it all. In PHP, the rule is that if we have plus, it's either an array or integers. So pros get status returns process information and it asks for resources and it's unpackaged. But let us go ahead and look for the structures where we can change type. And then we would attach this structure to our execution code. If we manage to do that, then we can rewrite pros information. So what we do is we look at all these things and identify the problems that we might encounter. The structure is called or not called. So basically, this is it. This is the kind of exploit that we get. So then it either goes through GMP for PHP 5. In PHP 7, it's even simpler. The gadget is right on the surface. You don't have to bypass git status. You can just use it. Full advisory is going to be in our GitHub and in our Telegram channel. That will be all. Thank you for your attention.
Какие-нибудь вопросы?
Any questions? Yes, I can see you. Please wait for the mic. Right. My question is the following. In current realities, where bug researchers not always can get CVID, and they have to use regulators to send the vulnerabilities. Do you look at where to search for these additional bugs that are not in CVS, but they're going to be in some kind of local repositories? Well, we search for everything ourselves. What we described is not fixed for quite a long time. This one has not even been mentioned. So we look for the bugs ourselves, and we have a correspondent base. So the way the analyzer works, we get the patterns for binary vulnerabilities, put it into solver, and it solves and gets this. And what happens next is we'll look at how it how it works for this particular developer. Thank you for this presentation. It's been very interesting. On my part, it's not really a question. How about making a virus total or something so that you can just send a link to an open project as such, like to make sure on developing stage you can check whether or not it's secure. You know, do you think it's doable? Well, I gave you very brief information about the project, but it's there, it's working, and we're going to promote it further. And probably what you are referring to is going to happen in the short time frame. I'm not sure yet. I'm not sure what the way forward, but I guess it's going to be available for every particular user so that you can use it to check for yourself. Thank you. Thank you for this presentation. I would like to clarify why your examples refer to PHP 5. What versions your exploits and vulnerabilities are relevant to? Well, we actually did mention the versions.
Вот, ну тут по факту мы успели рассказать только о двух уязвимостях, да, вот это.
We told you about two vulnerabilities for PHP 5 and this one for PHP 7 and 8. It's not fixed. Not just for 5, for different ones. And you can see here the numbers. Everything is here. So yeah. Oh, okay. Right. Probably. Yeah. I had the wrong impression. Like I said, well, first off, it's just a conference, right? And we are telling you about the bugs that, that is relevant to the context of the conference. Thank you for this presentation. Protection by application inspector and the like, do you think it's going to be deployed? Yes, that's where I started. Back in 2013, we developed application inspector and it developed, and now the new projects hopefully will develop further as well. It's going to turn into a product in the nearest future. It's probably going to be available, universally available to all the potential users. We don't seem to have any more questions. Please select the most interesting question. The guy in the gray t-shirt. Thank you.